Hello guys, in today's video tutorial we are going to simulate a Jenga tower. This will be a playful simulation and we can discuss together some parameters that we can calibrate in Abaqus user interface. Okay, let's start and set up our model together. So let's create the bricks. Let's create the brick. Let me check my note. I have noted the dimension of the Jenga brick. Okay, let's name it as a brick, solid extrusion, and we're now in the sketcher of Abaqus. Let's create a file, and the dimensions are 75 and 25 millimeters, and select here, exit the sketch, and the thickness of the brick is 15 millimeters. Okay, now except of the brick we shall need a rigid ground. That will place our tower on. So let's create an analytical surface. Let's name it ground, and let's just create a line. Let's 50, 500, exit, and here is the other dimension, 500 as well. Okay, nice. So now let's also create a point in the middle of the surface. That this one is yellow point, and let's create a reference point here that we'll use it as the point that will assign our boundary condition on. Okay, let's move forward and create the material of the bricks. It's not of high importance. Let's create a wood, and we have to consider the elastic properties. Let me check my notes. It's about 10 gigapascals, so we have to include the value in megapascals, 10,000 megapascals, and the bond ratio 0.3. And because we are going to run a dynamic analysis, and we have to include the density of the mass for the mass of the bricks. Let me check my notes. 0.7 minus 9. It's okay. So we're okay. We have to create the relevant section. Good. Continue. Yes, perfect. And no need to assign a section on the analytical rigid surface, only on the brick. We have to assign it, and it's okay. So let's also mesh the brick. Okay, nice, very simple geometry, green color, structure mesh, hex structure. The only that we have to do is to assign a value for the global size, 7.5, let's make it 5. So we're not going to address problems that will have to do with element distortion or other convergences in our simulation. So let's also assign an explicit family element library, and let it as is, hex, okay. Let's mesh the part. Okay, now what I'm going to do, I have noted here also that I have to build a tower with 18 layers of bricks. So we have to include this and this. Perfect. So So what I'm going to do now is okay. Let's include some more bricks in my analysis. 3. Okay, 6 bricks. 3, 4, 5, 6. Perfect. Click this button to start assembly our bricks on the ground. Here we can see two opposite arrows that we have to turn the orientation. Yes, perfect. So let's also translate this. Click here, select an endpoint. It's okay. So let's start assembling the rest of the bricks here. Click, yes, nice. This with this, nice. That's something I don't like. Okay. And this to this, perfect. Perfect. Oh, it disappeared somehow, no problem. Okay, perfect. Now we'll have to move it a little bit. Let's undo that. Delete here. Okay, now here in the model tree you can see all the position constraints that we are doing, and you can go back and delete or edit them. So what I want to do now is that, okay, I will check, I will select this surface, and I will mate it with this surface. Oh, okay, nice. Abaqus, it's a little bit tricky on the assembly of the parts. So let's move forward quickly. Perfect. 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 So let's do the same. Perfect. Oh no. Perfect. Perfect. And the last one. Perfect. No, back, go back. Select this. Select this. Okay. And select this. Oh, it's okay. Okay, perfect. So now we have created 2 layers of our tower. So very easily now we can create a pattern. Select the 6 bricks and here we have select 1. Oh, no, 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 no. And here we have select 9. Okay, so our Jenga tower is ready. Perfect. So let's move forward and decide how and what we are going to simulate and then we are going to do. Okay, before create these time steps, it's better very easily create the interactions that I'm going to create one type of contact with a tangential behavior, a penalty method, and let's assign a coefficient of friction of 0.35 and a hard normal, a hard contact for that. Okay, so we can create an interaction, a general contact explicit. Okay, so first let's go back under the assembly tree and create the surface of the analytical ridges. This is always needed for the drop test. This is the brown color, it asked me, or the purple. I'm going to assign the brown color as the reference surface. So let's now create the general contact, and here you have to assign the interaction property that we created before. Perfect. What other is straightforward for our analysis? Okay, now we have to create the steps. We have to decide what we are going to do. What I'm going to do is to create the first step. I will try dynamic explicit steps, non-linear geometry on, and I'll find a step of 0.2 seconds. Perfect. So the history output has been created. I will calibrate it a little bit. I would like to put some values for the times that the requested values will be generated. So let's click the same here. Perfect. Okay. So let's now create the boundary condition and fix the ground floor. So assign the boundary condition 1, the initial step. We click this choice, continue, and we have to select the reference point of the ground floor. Click done and select and constrain all the degrees of freedom. Perfect. So what other I'm going to do is that right click on this selection amplitudes and create a smooth step amplitude 1, and let's assign these values 0, 0, and 0.2 is the duration of the step that we created before, and here the 1 value. Perfect. So we are going to start and play with the bricks. So I will going to create on the step 1 the first brick that I will put it off the tower by a displacement boundary condition. Let's click this surface. Nice. Click done and select U3, put the value of 100 millimeters, and let's click this amplitude 1. Nice, perfect. So what I could do it on several breaks in one step, but let's create the second step, the same explicit dynamic step, step 2, with the same duration, 0.2, and under the boundary conditions, second break. Step 2, displacement again, and let's click the surface, click done, and assign on the x-axis u1 minus 100, because this is the opposite direction, as we can see the coordinate system, amplitude again. So we can do the same for various bricks. Step 3, explicit, 0.2, it's okay, boundary condition, create, and let's do the same for this brick. Oh, hit continue, click the surface, okay, now let's hit it. The same amplitude one, perfect. 4, same procedure, 2, create, this will be the 4th brick, and let's click the surface, 100, and, let's same, step 5, 2, create, what to do now? Okay, let's click displacement again, let's take this surface, and it's minus z. Okay, so in the final step, let's give a little more time to see the tower falling. 2 seconds, but also we will make a displacement, and let's put off this one. Minus z. Again, the same amplitude for 0.2 seconds. It's okay. Oh no, it's not too good. The direction of the arrows is the opposite. Now it's okay. Perfect. So what we forgot to do is that what will be that will make our tower fall down will be, of course, the gravity. So we have to include our gravity, the first step, gravity load, and it will be in the y-axis in the opposite direction. So we're working in millimeters, so have to include this value. Perfect. You can see the arrow. Okay, now I can see it. So now, after having created all these boundary conditions and the load of gravity, we have to go here, click here on the boundary condition manager, and except of the first boundary condition, which is the fixed support of the ground floor, and shall be active during all the analysis. We have to deactivate it. The other steps, basically every other boundary condition shall be active only for one step. So let's go here, click here and click deactivate for this, here for this, here for this. It's okay, so we are now ready to create a job. I am already running some same jobs to show you the result quickly. And let's name it Jenga B. Okay, let's choose the processor that you want to split your domain. Click OK and right click submit. As I said previously, I have already run a same analysis, so I can show you the results immediately. So let's click right click here, the evolution of the analysis. Step by step, you can hear every step, and the last step, 6 steps, is a little bit longer. Okay, this is the gravity. Okay guys, I hope you liked my video. Stay tuned for next videos and thank you for watching.